All right, guys, can you hear me? Okay, let's get started. So I'm going to share my Scholar screen. We still don't know what the problem is, to be honest. I mean, but I believe we are not getting access to that GPU for some reason. We're going to have to call the people that manage this to see if something happened, there was a bug or something that is only giving us CPU access. But the CPU access should still work. So what we're going to do now is we're just going to go over how to use SKlearn for simple, traditional machine learning. Okay, so at this point, I am sharing my Scholar screen. And I'm in the folder already, so I'm just going to create a new script. I'm going to call it SKlearn intro, basically, .py. And we're going to start building a script from scratch that we're going to be using. All right, so I'll just follow along, basically. So the first thing I'm going to import here is SKlearn itself. So I'm going to do import SKlearn. All right, and as I need to, I'm going to import other libraries. I usually just import Numpy right away and pandas. So I'm going to import those two. Import pandas as Ph.D. And I'm going to import Numpy as NP. All right, then once I have these libraries, I'm going to need to do a few things. So one of the things I want to do is I want to be able to get iris data, right? So I'm going to get the iris data from somewhere. So I'm just going to create a variable here, and I'm going to call it iris, right? So I believe I made this iris available in the GitHub. So if we go to the GitHub with the browser, GitHub. And this is also on Brightspace. You can download it from there. But on here, under SKlearn, I have iris dataset. So I'm just going to download it. Right, you can see that there. Okay, so you can go ahead and download that. All right. All right, so I have the iris data set already on here, so I'm just going to move it. I think I should have it there. So let's take a look at this. All right, so it's there. Can you guys see it? Guys, are you hearing me or you guys hear me?
Yeah, we can.
Okay, all right. All right, so hopefully you can see that I'm sharing right now the Iris data set. So you can just download it from the GitHub, or you can download it from Brightspace. You can see that here, the columns or the labels are, sorry, the labels are the first column. And then I have the 4 features, 1, 2, 3, 4, right? So each one of these is a row. So I'm going to need to load that data into SKlearn. Now the name of the file is cstraining.csv. But the file that you download might be just iris.csv. All right, so where is my terminal? Here. So what I need to do, so you should be seeing the terminal now. Okay, and I'm going to load the data. So I need to do numpy or numpy equal open, right? And then I'm going to specify the name of that file, which was, what was the name of that file? CS-training CSV. Okay, CSV. And I'm going to read this file. So by default, read. Okay, and that's just going to be my iris data. And then I'm going to use NumPy, for instance, to load the data. So I'm just going to say matrix data equal np.load txt fnumpy. Delimiter is comma. Delimiter, comma. And then skip rows. We don't have to skip rows, so I'm gonna just ignore that because we don't have any headings. But if you had headings, then you would do skip rows equal 1. All right, so I'm gonna save this file. Okay, I'm gonna try this. All right, so that worked. So that means that the file was read. So I'm going to go back into the script now. And that's how we have our data here loaded into SKlearn. Right, so that, as you can see, we use NumPy to conveniently load our data. NumPy's built-in load txt function, and then we just specify where it is. Okay, as I said, if you had a heading, you would probably want to include skip rows equal 1. All right, then now the question is, this data is now a NumPy array. So remember, NumPy arrays is one of the topics we need to cover in the class. We'll need to go over that, but the idea with a NumPy array is literally that it's like a little matrix, right? So that data that we saw over here, when we open this, right? So this data. So what I want to do now is I want to separate the data. So for instance, I want to take the first column and I want to assign it to a vector. And then I want to take the other 4 columns. So for instance, these, right? These 4 and everything below, and I want to put them in another one. So that's called slicing, and I believe we talked about it in the slides a few days ago. So now we're just going to implement that. I'm going to go move this. I wish I could get rid of this thing. It's always in the way. So I'm going to go back to the terminal. So you should be seeing the terminal, and I'm going to slice the data. So what I need to do is I'm going to separate matrix data into X and Y. And notice that by convention, I'm going to use uppercase X for the data and lowercase y for the labels. So I already know that the labels are located in matrix data. All right, and I need to do all rows. So I'm going to say colon, comma, and then I'm going to specify that I only want the first column. So that would be 0. Okay. Then for the X data, I'm going to say matrix data. And I'm going to kind of do the same thing. This time I want all rows, but I only want the columns that are from what? From 1 all the way to the end. All right, so that should give me all the data that I need. I can then, if I'd like to, I can try to print this just to see what it looks like. So I'm going to do print X, for instance. I'm going to print X, Control X, yes. All right, I'm going to run it. And you can see if I scroll all the way up, I have 5.7, 2.9, 4.2, and 1.3. So 5.7, 2.9, and you can see, yeah, 5.7, 2.9, 4.2, 1.3. So I slice basically the first 4 columns, you know, columns 1, 2, 3, and 4, right? If you look at the next one, 7.6, 3.0, 6.6, 2.1. So we have to look for 7.6, 3.0, and you can see that here, 7.6, 3.0, 6.6, 2.1. So I've sliced that out, and that's all the data. And then in another one, I'm going to have this column. So if I print the Y now, go back to the script, and I'm also going to print Y, I can take a look at it and see that there it is. Those are the labels. You can see it's labels 1, 2, 1, 0. So if we go back to this, 1, 2, 1, 0. So you can see I've sliced that out as well. So that takes care of my data. I have X and Y there ready to go. And now I can proceed to do my machine learning. So whenever you do machine learning, especially in Python, you always end up dividing the data into a vector called Y, which represents the labels, and a vector or a matrix called X, which is the data itself. As you can see, by doing this, you ensure that the data is still aligned and there aren't any problems. Are there any questions about this? No questions? We've had so many problems today that you just confirmed that you guys are still there. You can hear me?
Yeah, still here.
All right, great. All right, so now, now that I have the data, the next step would be to normalize it. All right, so we're going to try to normalize our data here. All right, so we're going to need the standard scalar from SKlearn. So I'm going to go up here. I'm going to go up here. I'm going to do from SKlearn, dot pre-processing import standard scalar. Okay, so remember what I said about scaling. Scaling is always something that you should do in machine learning. It will just allow your model to be more stable and to learn better, basically. So it's something that you always should do, right? So as you look at the pipeline, you can follow always kind of this approach. Libraries, get the data, slice out the data. Obviously, this is going to vary, but usually this is the standard approach that we want to take. Okay, so I'm just going to add this section here, and I'm going to say, I'm going to add a comment, feature scaling. And I'm going to say, I'm going to create an object, SC for standard scalar, which is going to be standard scalar. So that's the object that we just created. All right, and now we can apply this to our data. So I'm going to first train now I'm going to train sc.fit. Remember that basically SKlearn has these functions, fit, predict, and it's really, one trains the model and then the other one applies the model. So in this case, I'm going to fit the data using X. Okay, so I'm going to train sFitX. And then I'm going to do X scaled or normalized. Let me use that terminology. Normalize is the same thing. We basically normalize the data. So I'm going to apply this to the X data by doing sc.transform. And the data that I get is basically X. So what I'm doing is I learn how to build a model for scaling from the data, and then I apply that model to the data, and I create a new version of the data called X normalized. Okay? I'm going to go ahead and run that. I usually like when I do the scripts, I just put print done so that I know that it did what it was supposed to do. All right, so I'm going to run this, and I'm going to also print X normalized. All right, so I'm going to try this. All right, and you can see the data. Let's take a look. So this is what the data looked like originally, right? So we had 5.7, 2.9, 4.2, 1.3, right? You see this first row. Now, after I apply normalization, look at it. Minus 0.13, 0.25, 0.22, 0.11. So it's still, the data is still there. It's just that it has been normalized from the range that it had in from 1 to 6 or whatever into a range between -1 and +1. So that's all that has happened. But the information is still there, is just now normalized. And as I said, this type of normalization is critical to machine learning. You will always, pretty much always do it. And it just helps the model to learn better. So remember that idea of the giant walking through those mountains and ridges. Well, this will help the giant to find his or her way. Okay? So now that we've normalized the data, we can go back to our script. All right, to our script. So I'm going to continue here. After I normalize the data, the next thing I have to do is I'm going to split the data because I need to have a train set and a test set. So split X and Y into train and test, right? So we, just like you did when you did the percentage split in Weka, now we're going to do that kind of manually in SKlearn itself or in Python. So for this one, we're going to need a module in SKlearn called train test split. Right, so I'm going to go up here, pull up to the libraries, and I'm going to say from SKlearn, dot cross-validation import train test split. Right, so I have that function that will allow me to very easily do the split. So the way that works is I'm going to add a comment here, and I'm just going to say 70% for train and 30% for test. Okay, so 70% train, 30% test. So that means I need to have a 0.3 factor there for the test size. So I'm going to create now. Notice that before we only had X comma Y, or sorry, X, Y. Now we're going to have 2 of these for train and 2 of these for test. So I'm going to have to create X underscore train, comma, X underscore test, comma, Y train, comma, Y test. Okay, so I have my X train, X test, Y train, Y test. And then these 4 are the outputs of running train test split. Right, so train test split. And so train test split, and then the inputs to this are going to be X comma Y, right? So my data. Where's that coming from? That's my X and Y up here, right? That's the data that originally contains the iris data set. We've looked at it a couple of times. So I'm going to now split it, and I'm going to specify the test size, which is going to be equal to 0.3. Okay, 0.3. And I could define, if I want to, a random state, and I can specify any number, so 42 or something. So this is the advantage of using that, is that random state will actually randomize the data before it does the split. However, keep in mind it randomizes the indices, right? So that means that the labels and the data, the feature vectors are still aligned. Okay, so they're still going to be aligned. It doesn't matter, if it moves a vector somewhere, it's going to move the corresponding label as well. So they continue to be aligned, and that's really great. So because otherwise we would lose our data. But here we still get our data aligned. It's just that now it's randomized as well. And 30% of the data will be in the test sets, and then 70% of it will be in the train sets. Okay? So I'm going to go ahead and run that one. Are there any questions, comments? Guys, any questions or comments? Am I missing something? Did I do something wrong here? If you're following the logic of my code, is there something that's not correct? You guys can hear me, correct?
I can. I keep forgetting to hit the mute button.
Yeah, so what am I missing? What's one thing that I haven't, if you're following the logic of the code, because this is the data that I'm going to use in my training and testing, right? We're almost there, but if you're reading the code and following it, you should notice that there's something that's not correct. What is it? Should I be using X or X normalized? Guys, should I be using X or X normalized? So I should be using X normalized. Somebody wrote something. Yeah, X normalized, exactly. And if you can speak, that would help me because I literally have way too many screens right now. And I'm starting, so many, in fact, I'm getting confused. So, so it would really help me out if you guys speak instead of writing on the chat. But yeah, so the X normalized is what we have to use because remember, the original data is X, right? The original data is X, but I showed you what it looked like. And then after that, I normalized it. And then after normalizing, obviously that's what we want to use, X normalized. All right, so I'm gonna try this. I like to run this always just to make sure there are no error. Okay, there's an error there. Okay. And this might just be that this is no longer standard scaling, train test split. It's probably, so model selection, let me try model selection here. Yeah, so it works now. So one thing about these libraries that I think I've said many times, and you just have to live with this. As you have a lot of innovation, which you guys are experiencing, I would say unprecedented innovation in these areas of AI, the libraries are constantly being changed. And you're just gonna have to kind of learn to live with that. If that happens sometimes, Google it and you'll find that they've rearranged the functions and they put them in another module. All right, so that's unfortunately how it is. All right, so that's just going to be pretty common. All right, so now we have the data. Now I ask you another question that's important. why did I only normalize? Do I need to normalize the y? Notice that I normalized the x's, right? But did I need to normalize the y data as well, the labels? Yes or no?
No.
No, you don't, right? And that's a very good answer because the labels are usually just going to be what? 0, 1, 2, you know, or 0, 1, 2, 3. They're always going to be basically just these fixed numbers, right? Nominal numbers. And so you do not need to normalize the y's, right? So remember that. So maybe I'll write this here. You know, you only need to normalize the data, the x data, the feature vectors, the x data, or remember the terminology, the feature vectors. That is essential, but you don't need to do that for the y's. All right, so now we have our data. This ran, okay? And so now we are pretty much, that completes the pipeline. Usually this is, in its simplest form, this is all you have to do. You fit the data, you scale it, and then you split it. Now that we've split it, you're going to see how easy it is to just run one algorithm. So I'm going to take one of the algorithms from, one simple one from Weka. Let's do KNN. So I'm going to do KNN. So for this, I'm going to need to define a function. So I'm just going to do it up here. I'm kind of just going to define a little function for KNN. Okay. So I'm going to do, you know, define KNN, you know, RC, right? And then I'm going to do, I need to use the data, right? So it's going to be X train, X test, Y train, Y test. Okay. All right, and then in here, I just need to define what the function will do. So 1, 2, 3, 4. And I'm going to do from SKlearn dot neighbors, right? Import KNN or neighbors classifier. Okay. So once I create that, I'm going to do then the object KNN equal the KNeighbors classifier. KNeighbors. Just trying to make sure I get this spelling correct. Classifier. And then I'm going to do n neighbors. And if you remember in the algorithm, this just means that the 5 closest samples will be looked at. So I need to specify that number. So I'm going to say k neighbors equal 5. All right, we're going to specify a few other parameters. Default parameters, p equal 2. And the metric we're going to specify as Minkowski, which is just one of the distance metrics that it uses. So these are, you can always, as I said, just use default parameters with this. So now I'm going to do knn.fit. And remember, all these models have fit and predict. So I'm going to do knn fit Now I'm going to use the train data to fit. So I'm going to say X train and Y train. And then I'm going to say I need to, once I've fitted the model or trained it, I need to predict. So I'm going to do ypred equal knn dot predict. And what do we predict on? What parameter do you think would go here? So what parameter would go there? Guys? All right, so in here we would have X test, right? So X test would be the matrix that we're going to predict on. All right, and that should give us then the result. So I can just, for now, I'm just going to do print ypred, and I'm just going to test to see if this works. So I'm going to do print ypred. Now that I've defined my function knrc, I'm going to call it from down here. So I'm going to say knrc. I need to plug in the value, so it's going to be X train. Now notice that these are the data sets, right? That's the data. So the variables that hold the matrix and the vector. So I'm going to say X train, X test, Y train, Y test. Okay? So now if everything worked out and if there are no errors, it should print out the results. So I'm going to go ahead and run this. Clear there. All right, so it's not K names classifier. Here probably. K neighbors. So it found K neighbors, but I had a typo, I think. All right, so I'm going to try it again. All right. So it worked because I see the done. And this vector here has my results. So now you can build. So now you can literally, you have more power, right? Because in Weka before, you were kind of tied to that little GUI and analyzing the data. But guess what? Now you have automation. You have a Python script now that can predict labels. So if this was, you know, stock market information, now you have actionable results. You can take this vector and maybe it says that for this stock buy, you know, for this other stock buy, but then for the third stock do not buy, fourth stock do not buy, fifth stock buy. And so you can now automate the entire process. Does that make sense? Guys? So the implication of this is quite big, right? You actually have way more power now because you can, just by writing a little Python script here, now you can take some data, you know, you've looked at stock market data for a decade, and then you feed it some new data, right? In X test and Y test, the data that you collected, you know, in the last week or this today maybe, and now you run it through your little algorithm here, and now it predicts. It predicts ypred, And then this ypred now, as I said, is actionable results that you can make decisions on. So hopefully that makes sense. I remember, to me, that was pretty exciting when I learned how to do this because of the implications, right? You can start full automation now. And that completes the pipeline of SKlearn. So as you can see, pretty straightforward, actually. So at this point, are there any questions?
Not presently, no.
No? Is all of this clear? Making sense? All right, so it seems like it's clear for everyone. That's good. You'll have questions with your homework, but this is making sense. All right, so now let's go to Brightspace, because on Brightspace, I actually provided some code that you can just use from there. I'm going to go to Brightspace, and you do the same, please. And just, we're going to download that code so that we can use it. And that way we don't have to type it. All right, so let's go to the SKlearn, and on here I provided these files. So starter.ml code and SKlearn code. So basically, download that one, and basically download this one. Okay. So now we need to find them in our system here. Go to home. Downloads, I'm assuming. Yeah. All right, so we can open them in the text editor. Can you guys see the file I just opened in the text editor?
Yeah, I can see it.
Okay, great. So as you can see in here, a lot of it is what I just wrote. I have KNN in there. However, I have a lot of the other algorithms already in there. So we don't have to type them, given that they're pretty much consistent. So what I'm going to do is I'm going to copy this function, which is the print metrics function. All right, and I'm going to copy that in here. And we may need to tweak it a little bit, but hopefully it'll just work. All right, great. So we have our print function there, first of all. So let's start with that one. So what is this print function? So if you remember some time ago, I said that the goal of the print function is to, just like in Weka, we do precision, recall, F measure, here in SKlearn, we want to do the same thing, okay? So then all we have to do is we're gonna add that function to our KNN RC. So we can do here, we can try to get the name of it. Doesn't quite fit. All right, so it's print. So it's print metrics, right? And then we can specify the algorithm. So in this case, we would say this is KNN, that's just for reference, comma, And then now here's the trick. We have to provide the Y test because that's the real data, the real labels of the test set. But we also want to provide Y pred, which is the predicted value. So what print metrics will do is that print metrics is going to start to compare, and it's going to measure, if you notice over here, it's going to measure accuracy score, precision score, recall score, F1 score, and the confusion matrix as well, okay? The conf map. So if I remember correctly, I think we have to add some things to some of these, but let's just see if it gives us any errors. So now I've added to KNN the function print metrics, if you notice, and I've given it Y test and Y pred, the two vectors that I want to compare. Another thing that I can do also, since I'm doing that, is I can print out Y test. Okay, so I'm going to print out Y test, and that way we can also manually inspect the results given that the data set is pretty small. All right, so I'm going to go ahead, hit Control X, Y, enter. Okay. Now I'm going to do that. So hopefully you guys are seeing my terminal. I'm also going to open the other file, starter.ml. Okay, so if you notice in this one, I have a few other functions for plotting regions. I have one called printstats tenfold cross validation, which is, if you remember in Weka, you have tenfold cross validation. So this one is similar, right? It'll allow you to do tenfold cross validation in SKlearn. We have one for printing the ROC curve, printing 2D graphs. So a lot of basically just helper functions. What I'm gonna do is I'm just gonna let you play with these. They're not part of the assignment per se. They're just helper functions that will allow you to have a little bit more visualization. So when you're done with the class and you have some downtime, I would strongly recommend that you try to incorporate these functions. Now they're not going to work with everything, but they will work with some of the algorithms. So I would encourage you to try plotting function. Definitely try the print stats tenfold cross validation. Try the plot ROC curve. Try a plot 2D graph model, all right? And so you can play with those later. All right, so now that we've done that, let's go ahead and try to run the code, see what errors it's going to give us. Missing parameter parentheses. Oh, okay, yeah, I know what that is. We can fix that. So let's just fix this. All right. I just added the parentheses there. Then I'm going to run it again. Another one of those. Okay. So that's down here. Okay. All right, so now the error it's giving us is, let's see, print metrics, okay, accuracy score is not defined. That just means that the libraries are missing. So I need to go up here, and just like we did for standard scalar and train test split, we will need to import the metric. So I'm going to say from SKlearn dot metrics import accuracy score from SKlearn metrics import recall score, comma, F1 score, comma, confusion matrix, comma, and are we missing one more? Or is that all of them? Yeah. Are we missing one? We're missing precision score. So I think that's all of them. All right, so now Control X, Y, enter. Run this again. Okay. And now it's saying precision. So precision, it's currently not liking that. And that's a missing parameter. But we can, so let's just do this. Let's just try, let's just leave accuracy there. And see if it'll run with just accuracy before we actually fix the other one. So I'm going to do Control X, Y. All right, so this time it worked. And you can see that at least for accuracy, it's giving me a 90% score. You guys see that at the bottom? So for algorithm KNN, we get an accuracy score of 90%. Questions so far? Guys, any questions? No questions? Are you guys still there? Did you fall asleep? Are you guys following along?
Far so good.
All right, so far so good. Okay. All right, so that's the KNN and accuracy. Now we're going to proceed to fix the other ones, right? So we have to fix these functions. That's the key thing, given that you will be using these functions quite a bit. Later on in TensorFlow 2, we're going to learn that there's other ways of calculating them, but it's the same metrics. It's just as I said, every library has their own version of the same thing, right? But with this function, you can actually use it even if you were using TensorFlow or PyTorch. You could still use it quite easily. So let's go ahead now and figure out what the other problem is. Okay. So now the error is in precision, and I remember that we're basically missing a parameter here. We are missing parameter that goes here. Okay, so let's see. See if I can figure this out. So what was the error that we got? We have to run it. So the error is target is multi-class, but average is binary. Please choose another average setting. One of the non-micro weight, I think it's weighted actually. So it should be average equal weighted. I think that's the solution. So so remember, average equal weighted. All right, so let's scroll down here. And now I'm gonna add comma, average equal single quote, weighted. All right, so a weighted average. And it's because, as it said, target is multi-class, which is true. Iris is not binary, right? So binary would be, you know, is it Democrat, Republican, 2 classes. But Iris is a 3-class problem of Setosa, Virginica, versicolor. Right, so I changed that in the code, so let me run it now. And it runs, there you go. So precision is there now, and we get an accuracy of 90, precision of 90. So I'm gonna go ahead and fix that for all the other ones. And so I'm gonna do, right, so I'm gonna try in recall, comma, average equal weighted, and then I'm gonna do F1 measure. Weighted. And then I'm gonna do, I don't remember if confmat needs that as well. I'm gonna leave it like that for a sec. Oh, it doesn't need it. So as you can see now, I have my result for the KNN algorithm. I get an accuracy of 90, precision of 90, recall of 90, F1 measure of 90, confusion matrix, you can see there. And it only makes 3 errors. You can see that here and here. All right, so that's good. Are there any questions? No questions? All of this is making sense? All right, well, feel free to ask questions if you have them. Otherwise, now that we've got all of that built, let's see what else we can kind of harvest from this code. So you can see here I already used, so let's see. The libraries, then we have warnings. We already did this with the data. Label encoder we will address later. We did the normalization. We got our print metrics working, which is great because you'll be using that quite a bit. Then I did KNN, so that works. Oh, let's do one more thing so I remember now. So let's go to the terminal. Control X. And if you notice, I printed these 2 things, right? So the first one, if I remember correctly, that was the actual test labels, so the real labels. And then the next vector is the predicted labels. So if you look now, you can actually compare the errors. So you can see here, for instance, the correct value is 2, correctly predicted 2. Then the next one was 1, here it made an error, right? 2. Then I have 1 and 1, 1 and 1, 2 and 2, 1 and 1, 2 and 2, 2 and 2, 2 and 2, 1, 1, 0, 0. You can see they all match pretty much, except here, there's an error. The real value was 1, it predicted 2. Down here, we got 1, 1, 0, 0, 1, 1. Here's another error. The real label was 2, and it predicted 1. Then we got 1, 1, 1, 1, and so on. And you can see that. Now, we usually will not be able to do this because you're going to have so much data. But at least you can do it this, you know, in this example. That's why Iris is helpful, just to kind of help you with the concepts, right? Help you to grasp the concepts. All right, so are there any questions about what I just did here of comparing the real data to the labels? Any questions? Okay, there seems to be a question. Why was average equal binary? Was creating the problem earlier. Okay, what was the problem before? Yeah, that's a good question. So her question is, why did we have to change it to this? So the algorithm by default was assuming that our labels were binary. That is to say that we only had two labels. For instance, 0 and 1 or -1 and 1. So that's what it was saying. But Iris is multi-class, and that means that it has more than two labels. It has three, right? It has, what do you call it? Virginica, versicolor, and setosa. And so that's why we just had to tell the algorithm that it was multi-class. And the way that to do that is to tell it average equal weighted, basically. It's got four options. I don't know if you saw in the error, but it had four options, and you would literally have to read precision score. If you're like wondering how you would fix it on your own, you would have to look up precision score for SKlearn, find the parameters, and then it would list that for this, there's like 4 parameters, and then it would say which ones are for multi-class. And then based on that, you would know, oh, okay, I need to change it to average weighted. Does that make sense? Or does that answer your question? Okay, great. So it seems like Nupur's question has been answered. All right, so now let's go ahead and continue. Now, are there any other questions, actually, before I continue? No? All right, so from the code that I posted on Blackboard, we've already addressed all the libraries. We've already addressed reading the data. We addressed scaling the data. We addressed the helper function. That works perfect now. I have KNN already. Now notice I provided actually 2 more algorithms just to kind of help out, so we don't have to type them, right? So I have decision trees and logistic regression, which you implemented these in Weka, right? So if you remember, this was called IBK in Weka, or IB1, I think. This one was called, can anyone tell me what this one was called in Weka? What was the name of this one? Decision trees. Right, so somebody is asking me if they run this code with another data set, it's giving them errors. So did you change how you slice the data, how you read it? Because it's not gonna just work right away, right? You have to adapt it to the new data set. But we'll get to that in a second. So did you change it, or did you just change the name of the file? Yeah, just a name. So obviously it's not like Weka anymore, right? You have to own your data now. But that's actually a good exercise. Give me the link of the data set that you used. Can you put it in the chat, please, and let me know when it's there? All right, so yeah, thank you. So what I was saying here is I provided these, and actually I had asked a question, what's the name of decision trees in Weka? For the interest of not wasting too much time, I'll just give them to you. So it's J48. Yeah, J48. And the other one is just the logistic regression, which you guys saw that. All right, so what I'm gonna do is I'm just gonna copy these, okay? That way I don't have to type them or anything. And I'm going to go to the terminal over here. Scroll down to where, somewhere where I had KNN. I'm just going to add a new, I like, I'm very into things being readable. So I'm going to paste that in there. And the student provided the link, so we'll get to that in a sec. All right, so now if you notice, I've added J48 decision trees. And I've also added logistic regression, right? So I've added two new functions. So let's go ahead and call one of these. So I'm going to just call decision trees RC and see what happens. So I'm going to go over here. I can actually probably just copy these as well. Okay. And I'm going to go to here. Yeah, no, I know I provided them. All right, so now that I have the decision tree in here and the logistic regression, let's just change the names. So it's going to be XTrain. And also notice, okay, so these are written a little bit differently. So these are XTrain, YTrain, XTest, YTest. Make sure that you follow however I define them in the function. Yeah, so it seems I did XTrain, YTrain, XTest, YTest. And I did the same for this one, XTrain, YTrain, XTest, YTest. So just make sure you follow that order. So it's going to be XTrain, YTrain, XTest, YTest, and then XTrain, oops, YTrain, and XTest, YTest, right? So let me just, out of just, things always break, I'm going to comment this one out. I'm going to focus on decision trees. I'm going to give it a quick look just to see if I find anything that might give me a problem. Okay, yeah, I can see already there's you're gonna have to change these to Python 3, the print statements. Make sure you change the parentheses. Print metrics should just work. And you know what? I'm going to disable this for now. Disable. All right. So I made the changes. Let's see if decision trees works. So I'm gonna Control X, Y. Hit clear. All right, so it didn't break. That's great. Great news, right? So you can see here, I ran decision trees. Now this is not very exciting because all of these are always being the same value. This is gonna, as I've always said, Iris is a very academic data set. It's meant for us to just really quickly practice things. As you start using other data sets, you will notice, differences. All right, so now you can see the confusion matrix there. Okay. So let's try the other one, logistic regression. So logistic regression, same thing. I'm going to look at it really quickly. Okay, everything looks good. So I'm going to enable it. And now let's see what happens. All right, so all are working. That's really good news. And look what happened with logistic regression. All the values went up. Whereas before, decision trees and KNN were giving you 3 errors. If you look at the confusion matrix for logistic regression, one of the errors went away. So now this one only gives you 2 errors, and therefore has much better results. Okay? Questions? All right, so now we look at, just really quickly, as you can see, the code is very simple. Decision trees and logistic regression are kind of the same thing. From SKlearn tree, import decision tree. Then you create an object tree. You provided default parameters. We don't have to worry about that. We fit, because later on we'll look at the algorithms, but for now, you know, just use default values. The algorithms help you to later on, so that you can later on start to tweak the parameters. Right, then you fit with X train and Y train, and then you predict with X test, and then you just simply calculate the print metrics. Same thing over here with logistic regression. You, from linear model, import logistic regression, build the LR model, default parameters again. You fit with X train, Y train, sorry, and then you predict with X test, and that gives you Y pred, and then simply you compare Y test to Y pred, and that's it. Now this feature I haven't tested yet. So this one I'm just going to enable, but basically what these two lines should do is that they should export a little file called tree.dot, and it's going to be a graphical version of the decision tree. So this is not available for every algorithm, but it may be available for this one. So let's try it and let's see if it creates the file. So I actually didn't test this before, so I'm not sure it'll work in this environment. You can see the file is not there yet. So now I'm going to run it. All right, so everything ran according to how it should. So now if we go over here, you can see the file is there, tree.dot. It's got contents in it, so we could probably visualize it. If I remember how to. Okay, so we go to desktop. So hopefully you guys are seeing my desktop. And then I'm going to, I guess, double click on this. Oh, okay. You need some kind of a viewer, maybe display. No, is it, what would be the tool for this, to view this in image viewer? Maybe, right, guys? So let's try image viewer. Open. Nope. Didn't work. I'm sure you guys can figure out how to view this image. If not, email it to yourself. I'm sure in Windows you can open it. I just don't know what app. The file is there, and I'm sure it has contents. I just don't know what tool to use to view it. This whole Scholar is pretty new to me. All right, I'll leave that to you guys to figure out, but if you saw it, if you're able to see it, probably just export it, send it to your Windows, view it there. It'll be a decision tree. So it'll show you, how the algorithm learned the branching points based on the features to classify something as Setosa, Virginica, or Versicolor. All right? Any other questions? All right, so actually we covered, although we lost some time today with the problems we had, we actually did cover everything, because I've already extracted everything from that file, right? So this file, I extracted everything. We've covered SKlearn, and hopefully now you guys haven't really asked that many questions, so I assume you understand everything. SKlearn, as you can see, the code is now running, right? So this code is running, no errors. It gives you, I think, since you've already done Weka, you know how to interpret this. So this is logistic regression, decision tree, KNN, and you're kind of just looking at the results there, and then you can compare the algorithm. So in conclusion, which one of these three algorithms does better for the problem? Logistic regression. Thank you. So now I should qualify that we can't say that logistic regression is statistically significant, or sorry, we can't say that the result that logistic regression is better than the other two is statistically significant. We can't say that yet. Okay. Right now, all that we can say is that experimentally we saw results where logistic regression seemed to be better. However, there is something called the t-test, which is available in Weka, and you can also implement it in Python. And when you do the t-test and compare the three algorithms, the algorithm of the t-test will actually be able to tell you, yes, logistic regression is better, and the fact that it is better is statistically significant. Or it might say it is better, but it's not statistically significant. In that case, it means that they're pretty much all the same. Okay? All right, so I believe at this point, I've covered everything. We have the libraries, imported the data, split the data, scale the data. I added the metrics function. And we tried a couple of algorithms, KNN, logistic regression, decision trees, right? Yep, and so that should be it. So KNN, decision trees, logistic regressions. That's three good ones right there. And you can research the rest. You can also search through my GitHub. You might find a few more examples of algorithms. So certainly I would recommend that you try that. Also try out those functions that I pointed out in the beginning. Okay, so I have a few minutes left, and a student wanted to know about how to load a particular data set that he gave me. So I'm going to go to the chat, and I'm going to click on this, and this took me here. Not sure what. All right, so that link gives me the zip file, so I'm going to save it. And I'm going to have to go to the, are you guys, where am I here? Oh, here. All right. Oh, okay, so the chat took me, well, when I clicked on the chat, it took me outside of this. How do I open that inside the chat? Okay, maybe in Scholar. You got this from Scholar, correct? Or from Brightspace, I mean.
Yes, from the Brightspace.
Which one? SKlearn?
Yes.
Okay. All right, so
But
it's
the very first one, the very first one.
this one, right?
Yeah.
Okay, let me see if I can. All right, this one. Okay, so this is the one. And then where is the data set? Is it you went to data folder?
Yeah, it's in the data folder.
Okay, and then this one, right?
Yeah.
Okay. So now it's downloading. I'm gonna need to go to downloads. Okay. And then it should be this one. So I'm going to do extract here. Okay. And then you have these three files, right? Which one did you grab? So you can see here, APS failure description, APS failure test set.
I did it with the training one, the third one.
Yeah, so either one, right? So now
Yes.
this is the file that I would control copy, and I'm gonna move to the desktop to 520, which is where I have my script. So now what I need to do is I need to look, so what I would do is I'm gonna look, I know what this one looks like, right? And I know that my code worked with that one, right? No mystery there, it's got no headings, rows, comma separated, pretty, and I need to know that the columns are the first label and the rest are features. So that's kind of where I need to be. Oops. Cancel. Now I need to go to that folder and I need to open APS train. So I need to open this one, gedit. And of course, this is not going to work right away because just look at the format. Do you see that? So it's got the class. Okay, it's got, so it's helpful in the sense that it does have a heading, right? That's definitely the heading because it says class and then this. And then these are the, you got to figure out what are the features here. You have to read that other file, the description file. I would say, you got to get, so one problem with this is you have to get rid of that. Okay?
Yes.
Once you get rid of that, that should work. So what I'm going to do now, remember the class, because of this, is the first column. So I'm going to save it. And it's called APS. Remind me of the name, guys, so that's to save time. APS failure training set CSV. It's a big file too. I should have picked the test one instead. Big file. Should be a lot of fun to do this for you guys. All right, did it finish saving? Okay. So then APS failure training set. So now I need to go. You can, if you're what I would recommend is maybe start with the test set first because it's smaller and then work your way to the training set. But let me, APS failure training set, I need to go to the code now. Okay, and now what I would do is I would go here, just kind of comment this one out, and I'm going to add a new one. Numpy. APS failure. What was it? What was the name?
It's APS failure training set.
Training underscore set?
Yes.
And then .csv?
Yes.
All right, and then we're going to say read. And then down here, I'm going to add this time I'm going to use skip rows because it does have a heading. Equal 1 or true. All right, so now these parts are not going to work, right? Because, you know, obviously I have to know the number of columns, the number of features, but I just want to see if it'll load at this time. So what I'm going to do is just add a little message here, and then I'm going to add a raw input, pause it so it doesn't break. So now I'm going to go ahead and run it. Okay, what does it say? Could not convert string to float negative. Oh, okay. So the problem there is that it's the NumPy. NumPy is trying to convert. If you saw in the data, you see the background here. It's got these negatives. You see that? And NumPy is trying to convert these into numbers right away. So you will actually have to, by hand, convert those NAs to numbers. Does that make sense? You'll have to write some Python code, or I'm pretty sure you can find pandas that will do it for you. You can also do it in Weka, but you literally have to somehow manually change those negatives to numbers. Make sense?
Yes.
Yeah, so you can see that the error did not convert string to float. So I'm pretty sure, I don't know the size, but Weka would have filters for that. You can also just write your own Python code, I'm sure. You could also just use Excel. I mean, if Excel will support the size of this file, just open it in Excel. And if I try to open this in here like this, see it does that. And then you just have to do, you know, this alignment here. I'm going to say that it's all correct. And there you go. So the problem is you can see the heading up here, but you can see there's these NAs, the negatives, change those to numbers. Otherwise, you can, there's many ways in which you can change this via Excel, via writing your own Python code, via also using pandas, using NumPy even. I'm pretty sure there's a lot of functions out there that you can use for this. Okay? So I leave that as part of your homework to figure it out. If you have questions, send them my way, but that should be the issue. And then after that, figure out the number of labels, figure out the number of columns, figure out the number of features, and based on that, you're going to determine how to do the slicing, because remember, you have to, just like I did slicing here, when I knew that there's only 4 features and the first column is the labels, you have to figure that out for every specific data set. Does that answer your question? Oops, whoever it was that asked. Sorry, Wayne. There we go. Was it Sarab? Sarub? Does that answer your question? Sarab? I don't know. She's not answering. All right. So anyway, that's it for today, guys. We're going to stop here for today. If you have any questions, just ask. But that completes basically our introduction to SKlearn. You have a lot of tools now to work on both of your homework assignments. If you have any questions, as you might imagine, the homework assignments are going to start getting harder and harder, obviously, or not as easy as before. But that's just more fun for you guys. All right. So that's it for today. We're going to stop here for today. Don't forget, you have 2 homework assignments due next Monday. No homework today. And then Mitch, if you're still there, if you can just stay for a few minutes so that we can plan what we're going to do about Scholar, please stay for a couple minutes. Otherwise, guys, thank you very much, and I will see you guys next week. Mitch, I'm going to end this session and then come back, okay? Just so that the video starts generating.
Okay.